Hello students, welcome to Breedmark Academy. Myself L.S. Nanda. Now in today's video, I am going to discuss the solutions of two mathematics questions that were asked in recently held JEE Advanced 2025 Paper 1 exam. Now this is the first question of this video. This question is a good problem on the topic of calculus and requires deeper understanding of the concepts. It says, let capital R denote the set of all real numbers. Define the function fr to r by f of x equal to 2 minus 2x square minus x square into sine of 1 upon x if x not equal to 0 and f of x equal to 2 if x equal to 0. Then which of the following statements is true? The first option is the function f is not differentiable at x equal to 0. The second option is there is a positive real number delta such that f is a decreasing function on the open interval 0, delta. The third option is for any positive real number delta, the function f is not an increasing function on the open interval minus delta, 0. And the last option is x equal to 0 is a point of local minima of f. Now students, we start solving this problem. Now students, we have been given a function f defined from R to R, where f of x is given as 2 minus 2x square minus x square into sine of 1 upon x if x is not equal to 0 and f of x equal to 2 if x equal to 0. Now in the first option, we have to check the differentiability of f of x at x equal to 0. But before that, we will check the continuity of f of x at x equal to 0. And for that purpose, we will have to find the left hand limit and right hand limit of f of x at x equal to 0. Now left hand limit of f of x at x equal to 0 is given by limit fx x tending to 0 minus, which becomes equal to limit of 2 minus 2x square minus x square into sine of 1 upon x x tending to 0 minus. Now just replace x by minus h where h is approaching 0. So this becomes equal to limit 2 minus 2h square plus h square into sine of 1 upon h h tending to 0. Because sine of minus 1 upon h becomes equal to minus sine of 1 upon h. Now students, this can further be written as limit h tending to 0, 2 minus, I am taking out h square common. Inside the bracket, I get 2 minus sine of 1 upon h. Now when h approaches 0, then h square will also approach 0 and 1 upon h will approach infinity. But the value of sine of 1 upon h will be a finite number lying in the closed interval minus 1 to 1. And when such a number is subtracted from 2, clearly we get a number lying in the closed interval 1 to 3. And again, when such a number is multiplied with a very small number approaching 0, then clearly the product also approaches 0. So that means the value of the limit is 2 minus 0 or equal to 2. Now students, from here we conclude that in the left neighborhood of x equal to 0, the value of the function f of x is slightly smaller than 2. Now similarly, we will find the right hand limit of f of x at x equal to 0, which is given as limit fx x tending to 0 plus, and this is limit 2 minus 2h square minus h square into sine of 1 upon h h tending to 0. Now, this can be written as limit h tending to 0, 2 minus h square common inside the bracket 2 plus sine of 1 upon h. Now students, again h square will approach 0 when h tends to 0, and the value of 2 plus sine of 1 upon h will give us a finite number lying in the closed interval 1, 2, 3. So again I can say that the value of this limit is 2 minus 0 or equal to 2. Now students, since the value of left hand limit at x equal to 0 is equal to the value of the right hand limit at x equal to 0 and further equal to the value of the function at x equal to 0, so I can say that this function f of x is continuous at x equal to 0. And moreover, in the left and right neighborhood of x equal to 0, the value of f of x is slightly smaller than 2, right? Now students, we move further and check the differentiability of f of x at x equal to 0. Now students, we will check the differentiability of f of x at x equal to 0, and for that purpose we will find its left hand derivative and right hand derivative at x equal to 0. Now left hand derivative at x equal to 0, which is f dash 0 minus, becomes equal to limit h tending to 0 f of minus h minus f of 0 whole divided by minus h. Now this becomes equal to limit h tending to 0, 2 minus 2h square plus h square into sine of 1 upon h minus 2 whole divided upon minus h. Now minus 2 cancels with 2, and this limit becomes equal to limit h tending to 0 minus 2h square divided upon minus h becomes plus 2h, and then it is minus h into sine of 1 upon h. Now students, when h approaches 0, clearly this first term will approach 0. Again h approaches 0 and sine of 1 upon h will be a finite number lying in the closed interval minus 1 to 1. So the product of h into sine of 1 upon h approaches 0, and hence I can write the value of this limit equal to 0. Now students, similarly we will find the right hand derivative of f of x at x equal to 0. So right hand derivative, that is f dash 0 plus, becomes limit h tending to 0 f of h minus f of 0 whole divided by h, and this is further equal to limit h tending to 0, 2 minus 2h square minus h square into sine of 1 upon h minus 2 whole divided by h. Now 2 cancels with minus 2, and this limit becomes equal to limit h tending to 0 minus 2h minus h into sine of 1 upon h. Now students, again the value of this limit is equal to 0 as per the same logic. Now students, since f dash 0 minus is equal to f dash 0 plus further equal to 0, so I can say that the function is differentiable at x equal to 0, and the value of the derivative of this function at x equal to 0 is equal to 0. Now since the derivative of this function is equal to 0 at x equal to 0, so I can also say that x equal to 0 is a stationary point. And from the previous discussion we know that in the left neighborhood and right neighborhood of x equal to 0, the value of the function f of x is slightly smaller than 2, and the value of function at x equal to 0 is 2. So this clearly means that x equal to 0 is the point of local maxima, right? So that means from here we conclude that option A is not correct, as well as option D is also not correct. Now students, we discuss the remaining two options. Now students, to check the remaining two options, we will have to find f dash x when x is not equal to 0. Now f of x is given as 2 minus 2x square minus x square into sine of 1 upon x when x is not equal to 0. So this means f dash x is equal to minus 4x minus inside the bracket 2x into sine of 1 upon x plus x square into cos of 1 upon x into minus 1 upon x square. Now x square gets cancelled and we get the value of f dash x equal to minus 4x minus 2x into sine of 1 upon x plus cos of 1 upon x. Now students, if I take minus 2x common from the first two terms, then inside the bracket I get 2 plus sine of 1 upon x, bracket closed, plus cos of 1 upon x. Now in the option B, it is given that there is a positive real number delta such that f is a decreasing function in open interval 0, delta. Now students, to check this option, I will take x greater than 0. Now when x is greater than 0, clearly minus 2x is negative. And 2 plus sine of 1 upon x is a number lying in the closed interval 1, 2, 3. So it is the product of a positive real number with a negative real number, which is clearly negative. Now students, cos of 1 upon x may be positive or may be negative. It depends upon in which quadrant 1 upon x lies. If 1 upon x lies in second or third quadrant, then cos of 1 upon x is negative. In this case, f dash x is also negative, or f of x is decreasing. But if 1 upon x lies in first or fourth quadrant, then cos of 1 upon x is positive. In this case, f dash x may be positive or may be negative. This means f of x may be increasing or may be decreasing. Now students, from all of this, we conclude that for x greater than 0, function f of x shows dual behavior. That means it is increasing as well as decreasing. Now I will explain it with the help of few values. Now in the first row I am writing sine of f dash x, and below it I am writing value of x. Now students, if I start with x equal to 6 upon pi, then at this value 1 upon x becomes equal to pi by 6. So you can easily find the value of f dash of pi by 6, and this value comes as negative. Now if I take a smaller value, suppose I take 6 upon 11 pi, then at this value I get the sign of f dash x as positive. When I take a more smaller value, suppose I take 6 upon 17 pi, then at this value I get the sign of f dash x as negative again. When I take a more smaller value, suppose I take 6 upon 23 pi, then at this value I get the sign of f dash x as positive again. Now if I keep on putting smaller values of x every time, then it is always possible to find such smaller value of x that will change the sign of f dash x. This clearly implies in any selected open interval 0, delta, the sign of f dash x does not remain the same. Now students, you can also understand it in this way. If you assume that in an open interval 0, delta, function f of x is monotonically decreasing, then it means for every value of x lying in this interval, f dash x is negative, right? Now in such an interval, you can always find a number alpha such that alpha tends to 0. 1 upon alpha lies in first or fourth quadrant, and cos of 1 upon alpha tends to 1. Now in such a situation, the value of the first term, that is minus 2x into 2 plus sine of 1 upon x, will become a very small negative number approaching 0. Whereas cos of 1 upon alpha will approach 1. So clearly the value of f dash alpha becomes positive. Now this contradicts our supposition. So practically it is not possible to have a open interval 0, delta in which the function f is monotonically decreasing. Now students, we finally conclude that option B is not correct. Now we move further. Now students, since all other options are wrong, so option C must be the correct one. But still I will explain it. Option C says for any positive real number delta, function f is not increasing in the open interval minus delta comma 0. This implies there does not exist any open interval minus delta comma 0 in which function f is monotonically increasing. Now here, not increasing does not mean decreasing. Not increasing means function f is both increasing and decreasing in the open interval minus delta comma 0. Now students, to check the correctness of this option, I will take x less than 0. Now f dash x is equal to minus 2x into inside the bracket 2 plus sine of 1 by x bracket close plus cos of 1 by x. Now when x is negative, then minus 2x is positive and 2 plus sine of 1 by x lies in the closed interval 1, 2, 3. And we know that the product of any two positive real numbers is always positive. So this means this first term is positive. Now cos of 1 by x may be positive or may be negative. It depends upon in which quadrant 1 upon x lies. If 1 upon x lies in the first or fourth quadrant, then cos of 1 by x is positive, and hence f dash x is also positive. This means f of x is increasing. But if 1 upon x lies in second or third quadrant, then cos of 1 by x is negative. In this situation, f dash x may be positive or may be negative. This means f of x may be increasing or may be decreasing. Now students, from all of this, we conclude that for x less than 0, f of x shows dual behavior. That is, f of x is increasing as well as decreasing. Now I will explain it with the help of few values. Now if I find the value of f dash x at x equal to minus 6 upon pi. Now students, since I have taken x equal to minus 6 upon pi, so the value of 1 by x is minus pi by 6 and it lies in the fourth quadrant. So the value of f dash of minus 6 by pi is positive. But if I take a greater value, suppose I take minus 6 upon 17 pi, then at this value 1 by x becomes minus 17 pi by 6, which lies in the third quadrant, then the sign of f dash x becomes negative. Now, if I continue in this way and keep on putting greater value of x every time, then it is always possible that I keep on getting different signs of f dash x. That means from positive to it will become negative, then from negative to it will become positive, and so on. So from this we can conclude that in any open interval minus delta comma 0, the sign of f dash x does not remain same. It keeps on changing. That means in any open interval minus delta comma 0, f of x is not increasing. Now students, you can also understand it in this way. Suppose you assume that in any open interval minus delta comma 0, f of x is monotonically increasing. That means for every value of x in this interval, we must get f dash x greater than 0, right? But in this particular interval, you can always find a value alpha such that alpha tends to 0. Cos of 1 by alpha tends to minus 1, and 1 upon alpha either lies in second quadrant or the third quadrant. This is always possible. Now students, in such a situation, the first term will approach 0. It will become a very small positive number, and the value of cos of 1 by alpha will overcome this value to give the value of f dash alpha as a negative number. Now since f dash alpha is coming as negative, so clearly this implies it is practically not possible to have any open interval minus delta comma 0 in which the function f is monotonically increasing, right? Now students, clearly the option C is the correct one. Now we move towards the next question. Now students, this is the next question. This question is based on the topic of matrices. It says, consider the matrix P equal to, in the first row, the elements are 2, 0, 0. In the second row, elements are 0, 2, 0. And in the third row, elements are 0, 0 and 3. Let the transpose of a matrix X be denoted by XT. Then the number of 3 by 3 invertible matrices Q with integer entries such that Q inverse equal to QT and PQ equal to QP is. Now students, in this question, we have to find the total number of 3 by 3 invertible matrices Q with integer entries that satisfy these two conditions. The first is Q inverse is equal to transpose of Q, and the second is PQ is equal to QP. Now since Q is a 3 by 3 matrix and we do not know the elements of the matrix Q, so I am supposing the matrix Q as, in the first row I am taking the elements as ABC, in the second row D, E, F, and in the third row G, H and I. Now students, we are given that PQ is equal to QP. So let's find the product PQ. Now we get the product PQ equal to a 3 by 3 order matrix, and the elements of its first row are 2A, then 2B, then 2C. In the second row we have 2D, then 2E, then 2F. And in the third row we have 3G, then 3H, then 3I. Now students, we will find the product QP and put it equal to PQ, and then we will compare the corresponding elements of both the matrices, and from there we will get the values of some of these variables. Now let's move ahead. Now students, let's find the product QP. Now we get a 3 by 3 order matrix. The elements of the first row are 2A, then 2B, then 3C. In the second row, the elements are 2D, then 2E, then 3F. And in the third row, the elements are 2G, then 2H, then 3I. Now students, since PQ is equal to QP, so I can keep both of these matrices equal to each other. On the left hand side, we have the matrix PQ. And on the right hand side, we have the matrix QP. Now students, since both of these matrices are equal to each other, this implies their corresponding elements must also be equal to each other. So from here, I can write 2C equal to 3C. This means C is equal to 0. Then I can put 2F equal to 3F. This means F is equal to 0. Then I can put 3G equal to 2G. This means G equal to 0. And finally, I can put 3H equal to 2H. Now students, we have got the values of 4 of these constants, right? Now we move further. Now students, let's use the second condition, and that is inverse of Q equal to transpose of Q. Now if I pre-multiply both sides of this equation with the matrix Q, then I get Q into Q inverse equal to Q into QT. This implies Q into QT is equal to the identity matrix I, because Q into Q inverse is equal to I. Now students, with the help of this equation, we can find the values of the remaining constants. Moreover, this equation ensures that the matrix Q will be an invertible matrix, because if I take the determinant on both sides of this equation, I get determinant of Q into QT equal to 1, which can further be written as determinant of Q into determinant of QT equal to 1. Now we know that determinant of Qt is equal to determinant of Q. This means square of determinant of Q is equal to 1, or determinant of Q equal to plus minus 1, which is not equal to 0. So this clearly means that matrix Q is an invertible matrix. Now students, we can write Q into Qt equal to, the matrix Q is A, B, 0, because the value of C we have found as 0, then D, E, 0, then 0, 0, I. And the matrix QT becomes AB0 in the first column. In the second column, it is DE0 and then 0, 0, I in the third column. And we have to put the product of these two matrices equal to the identity matrix. Now students, this becomes, on the left hand side, we have a matrix whose first element of the first row becomes A square plus B square. Then we have AD plus BE. Then we have 0. And in the second row, the elements are AD plus BE, then D square plus E square, and then 0. In the third row, we have the elements as 0, 0, and I square. And this is equal to the identity matrix. Now students, we will compare the corresponding elements to get the equations. Now from here, I can write A square plus B square equal to 1. I can also write D square plus E square equal to 1. I square equal to 1, which means I equal to plus minus 1. And I can also write AD plus BE equal to 0. Now students, since A, B, D and E, all of them are integers, and we are getting A square plus B square equal to 1. So this clearly means if A is equal to plus minus 1, that is A square is equal to 1, then B must be 0. Or if A is equal to 0, then B must be equal to plus minus 1, right? Similarly, if D square is equal to 1, then E must be 0. And if E square is equal to 1, then D must be 0. Now students, we move further. Now students, I can write if D equal to plus minus 1, then E must be equal to 0. Or if E equal to plus minus 1, then D must be equal to 0. Now we also have the condition AD equal to minus BE. Now students, if I connect all the above conditions, then I can write if A equal to plus minus 1, then B must be equal to 0. Now if I put the value of B in this condition, then the value of AD becomes equal to 0. Now since A equal to plus minus 1, so this means D must be equal to 0. And if D equal to 0, then as per this condition, the value of E must be equal to plus minus 1. And we already know that the value of I is equal to plus minus 1. Now students, do remember that the value of the constants C, F, G and H, they are all 0 in all the possible matrices Q. Now this is the first type of matrix Q. Now we move towards the second type of matrix Q, where A equal to 0. Now if A equal to 0, then the value of B must be equal to plus minus 1. Now if I put A equal to 0 in this condition, then I get the value of BE equal to 0. Now since B equal to plus minus 1, then it means E must be equal to 0. And as per this condition, if E equal to 0, then the value of D must be equal to plus minus 1. And again, the value of I is equal to plus minus 1. Now students, to find the total number of possible matrices Q, we need to provide values to the 5 variables, and they are A, B, D, E and I. Because Rest of the variables are all equal to 0. That is, the values of C, F, G and H, they are 0. Now students, to find the total number of matrices of type 1, the value of A can be allotted in two ways. The value of B can be allotted in one way. The value of D can be allotted in one way. The values of E can be allotted in two ways. And again, the values of I can be allotted in two ways. So just by using fundamental principle of counting, the total number of such matrices are 8. Right? Now similarly, we can find the total number of matrices of type 2. Here, the value of A can be allotted in one way. The value of B can be allotted in two ways. The value of D can be allotted in two ways. The value of E can be allotted in one way. And the value of I can be allotted in two ways. So that means again we get 8 matrices. So that means total we have 8 plus 8 or 16 possible matrices Q, right? Now students, clearly the option C is the correct answer. Now students, this is to inform you that I have created two separate playlists of paper 1 and paper 2 for JEE Advanced 2025 math solutions. So you can go to the playlist section of my channel and watch all of these videos. Keep watching my videos and enhance your knowledge of mathematics. Thanks.